Welcome to today's class. For today, I'll help you solve question 3 of your tutorial sheet for chemical kinetics. So before I start, just ensure that you subscribe to this channel so that whenever I post something, you'll be notified or updated. So let's start. So question 3 is saying, given reaction rate data for this reaction you're seeing here. So in this reaction, you can see fluorine reacting with chlorine dioxide like that in order to produce this and that. And then here, my main area of interest is just on the reactant part, not the product. So I'm going to concentrate much on the reactants, not the products, because rate law shows how rate depends on the concentration of what? Reactants, not the products. And then we have been given this table, which is having 3 experiments. And in these 3 experiments, we can see the concentration of the reactants for fluorine and chlorine dioxide has been given like this. And then the initial rates for all the 3 experiments were determined, and it has been given to be like this. And then A is saying determine the order of each reactant and the overall reaction order like that. So here on A, we must determine the order of each reactant. After that, we must determine the overall reaction order. So solutions A. So how can you determine the order of each reactant? So the first thing, we need to come up with the general form of the rate law for this reaction we have been given here. So rate law, or the general form of the rate law, is equal to, so just after the equal sign, we need to write K, which is the rate constant, and then we need to write the concentration of the reactants, because I said rate law shows how rate depends on the concentration of the reactants, not the product. So what are the reactants there? We are having fluorine like that, and then we are also having chlorine dioxide like that. And then this must be raised to X and Y, where these X and Y are the orders with respect to this concentration. So X is the order with respect to fluorine concentration you're seeing here, and then this Y is the order with respect to chlorine dioxide you're seeing here. And then this X and Y, in some other books they use A and B, so it depends with the one you want to use. For me, I am familiar with X and Y. And then once you're done like this, we need to determine these same orders X and Y. So how can you determine X and Y? So these are the orders with respect to these concentrations. Once we determine this, then we have answered the first part, which is saying determine the order of this reactants. So how can you determine X and Y? So we're going to start with X. So how can you determine with X? So this X, we're going to determine it with the help of this table you're seeing here. X and Y, these same 2 orders here you're seeing, we're going to determine this X and Y with the help of this table you're seeing here. So for us to determine X, we're going to use experiment 1 and 3. It will help us determine this order X. And then experiment 1 and 2 will help us determine this order Y you're seeing there. So let's start here. So we're going to say let for experiment 3 over let for experiment 1 like that is equal to. So here you just have to maintain the general form of the rate law like that, then you raise it to X like that, then you raise it to the order Y like that, over, then here you just have to maintain, write the general form of the rate law, raise it to X, then raise it to Y like that, and then you just have to substitute. So rate 3, on your rate 3 you come, rate 3 is here on experiment 3. So we are having your rate to be 2.4 times 10 to the power negative 3 meter per second like that is equal to, you need to write K, and then what's your concentration for fluorine on experiment 3. So that's your concentration, so that is 0.20 like that, and then you need to raise it to X, that's the order. And then what's the concentration for chlorine dioxide on experiment 3? That is 0.010 like that. Then you need to raise it to power y, that's the order. And then we have seen over there, and even this side there is over. So over let 1, what's on experiment 1, what's your let? It's A, which is 1.2 times 10 to the power negative 3 meter per second, like that. And then you need to write K like that. And then what's your concentration of Flolene on experiment 1? So it's 0.10, like that. You need to raise it to X like that. And then here, what's the concentration of chlorine dioxide on experiment 1? That is 0.010, like that, raised to power y, like that. And then here, what do you do? So on the first part here, you need to divide 2.4 times 10 to the power negative 3 over 1.2 times 10 to the power negative 3. When you divide this, you're going to get 2, like that, is equal to. And then here, what do? You can cancel this, it's common with there, so when you divide this by that, it's going to get 1. And then here, this can go like that. And then when you divide 0, you need to divide 0.20 by 0.10. Once you divide, you're going to get 2. Then don't forget, it's raised to x the power, like that. And then our aim is to determine x, so that's the order we want to determine. And then here, laws of indices, when the bases are the same, what do you do with the powers? You equate. So for it to be like 2 like this, which means it's having 1 on top, like that. And then here, our x is same as 1 when we equate the powers. So we're having x to be 1, so that's the order. So for the first part, order for Flolene concentration is what? 1. Then you're done for the first part, like that. Then you're done. So this is our answer for the first part. Just for they are saying for each order. And then we're having 2 concentrations here, so we are just done for Flolene. Let's do the same for chlorine dioxide. So I'm sure it's clear. So let me lab, and then we do the other question. So if you haven't watched that video I posted on Let Low, better you watch it so that you can understand clearly, because here I'm just solving, I'm not trying to explain everything. So, and then here, since we want to determine now y, we have determined x. I said we are going to use experiment 2 and 1, like that. So here now, what is on on experiment 2 or let 2? On experiment 2, what's your let? On experiment 2, we are seeing it's here, so which is 4.8 times 10 to the power negative 3, like that, meter per second. And then this side is equal to, you can write K. And then what's the concentration for Flolene on experiment 2? That is 0.10, like that. And then you should raise it to x the power. And then for what's the concentration for chlorine dioxide on experiment 2? It's here, which is 0.040, like that, raised to the order y, over, even this side we're having over, like that. So here on experiment 1, what's your let? Experiment 1, our let is here, which is 1.2 times 10 to the power 3 meters per second. Then you can write K, the let constant K, like that. Then what's the concentration for Flolene on experiment 1? So the concentration for Flolene on experiment 1 is 0.10, like that, raised to x power. And then you're having the concentration of chlorine dioxide to be 0.010, like that. And then here, what do you do? So here, the same thing that we did on the first part. So when you divide 4.8 times 10 to the power 3 divided by 1.2 times 10 to the power 3, what do you get? You're going to get 4, like that, is equal to, and then this side you can cancel this, it's common, so it's going to give us 1. And then when you divide 0.040 divided by 0.10, it's going to give us what? 4, like that. Then once you're having this 4, you must raise it to power y, like that. Then here, so let me just write it clearly here so that you can, so this side is giving us 4, then also this side 4, and then you need to raise it to power y, as you can see this side. And then here, since the bases are the same, you use laws of indices. So here it's having 1, so here you just have to equate the power, so therefore y is equal to 1. So even the order for y, the order with respect to this chlorine dioxide is 1. So you can write it like that. So order for this chlorine dioxide concentration is also what? 1. So that's the answer. So for the order, we're done. Now the same question is saying, and we need to determine the overall reaction order. So how can you determine the overall reaction order? So overall reaction order is just the sum of x and y. So for overall reaction order, you say overall reaction order is equal to x, the summation of x and y. Just have to add this order. So your x is 1 and your y is 1. So the overall reaction order is 2. Then you're done. Just like that. So in the first part, we have answered for the order for each reactant. For fluorine, it's 1. And then the order for chlorine dioxide is 1. And then the overall reaction order is just the sum of this x and y, which is 2. Like that. Then you're done. And then let's do B so that you can understand everything. So let me lab this. Okay, now let me solve for B so that you can understand clearly. So here B is saying write the rate law for the reaction. So how can you write the rate law for the reaction? Since you have determined the orders for each reactant, it's very simple now. So if you can remember what I said about rate just depends on the concentration of reactants, K, like that. And then here the concentration of what? The reactants. You need to write the concentration of the reactants. So you're having fluorine like that, and you can write it like that. And then what's the other reactant? You can raise it to power y. But here you know that you have already determined the values for x and y, the orders. So we said it's 1. We answered it to be 1. And then our y is also 1. But even without indicating 1, 1, it's okay. So just like that, then you are done for B. So this is the rate law for the reaction. And then C. So how can you obtain C, or how can you find for C? So C is saying calculate the rate constant K and state its what? Units. So how can you determine this rate constant K? So you can use this expression. I'm sure you know where this is coming from. So once you use this, they want this K, the rate constant. So how can you calculate for the rate constant? So you can make this rate constant K the subject of formula by dividing this concentration both sides. Once you divide this concentration both sides, you're going to have your rate constant K to be like this. So it will be rate over the concentration for fluorine and chlorine what? Dioxide, like that. Then once you are having this, you can do this now. So K is equal to, what's your rate? So your late, you can get it from these 3 experiments. You can get any, if you want this data from experiment 1, where you're going to get your concentration to be 0.1, or you can get this information from this data for experiment 2 or 3, but for me I'm going to use for experiment 1. So my late on experiment 1 is 1.2 times 10 to the power negative 3 meters per second, like that, over the concentration for Frolin on experiment 1, that is 0.10, like that, and then the concentration for chlorine dioxide, which is on experiment, which is 0.010, like that. And then when you work out this on your calculator, you punch, it's going to give you something like 1.2 meters, like that. So these are the units, because it said with its what units, and I explained on the video that I posted on late law. Now you are supposed to come up with the units. So this is how the question you're supposed to answer it. And then if you're having questions, you can contact me. There's a number in the comment section there, or in the description box, sorry. And then lastly, don't forget to subscribe, like, share, and comment. And thank you for watching.